Okay, all right, quickly. In our first session, we quickly went through electrochemistry again, if you remember, saying that everybody must get the marks here. We did this question. Then we saw a different shape of your galvanic cell. I know we are used to two cells separated, but this is another way of representing a galvanic cell. And you would see that as your salt bridge. So it's still a galvanic cell. I know we are used to things that look like that. And for a voltmeter that tells you it's a galvanic cell. So your half cell and your half cell. And we did some calculations, if you remember. We spoke about our normal stoichiometry, that it will always follow the same process, 3 steps of stoichiometry. Okay, all that done. What else did we do? Okay, this was still explaining that. Then we did acid and base question here, where we were looking for, what were we looking for? I don't remember. All right, percentage composition, which is percentage purity. I'm sure that as we continue, we would find a few more questions. Then we played around a circuit here, just to have fun, dealing with ESCOM stuff. All right, today we start from here and we look at photoelectric effect. Please remember, I don't need to remind you of the importance of definitions, that it is very, very key. Okay, so let's look at this diagram and let's see if we can answer a few things just by looking at the diagram. What can we pick from here? The diagram below shows a simplified photocell. And we know that we have incident light, the vacuum, and an ammeter. The ammeter will measure what? Current. The graph below shows the relationship between the maximum kinetic energy of the photoelectrons and the frequency of light when light is shown onto the surface metal. I did explain how to interpret this graph. Your y equals to mx plus c. The first thing I'm going to quickly put out to you is to understand what F1 is. What is F1? That's your threshold frequency. We shouldn't forget that. F1 is, and while we talk about that, can we define threshold frequency? Threshold means the minimum. So it is the minimum frequency of light needed to do what? Eject an electron from the surface of a metal. Please, at this stage, I want those definitions to pop out like you writing your name. So when you're revising and you see the concept, don't move, just read. Define those concepts as you go on. You remember a lot better. All right. Okay, that's what. Right? Lovely. Let's go check now what the question is saying. 5 minutes or so, I want us to be done with this without much stress. Okay, look at the first question. It says, write down the physical quantity represented by F1. I think we did that even before looking at the question. What is F1 again? Threshold frequency. Beautiful. That one is done. Define the term work function. We know that work has to do with energy. So it is the minimum energy of light required to do what? Eject an electron from the surface of a metal. Everyone again, we get that. Calculate the work function. We go to our formula page. What is the formula for work function? Everybody, let's get a formula page. I want you to identify the formula. I know you're used to it, but let's identify it again quickly. Your formula page. We know the formula. What's the formula? W naught equals to what? HF naught there. And I'm sure we all know what our H is. It's our Planck's what? Constant. 6 comma. All right, let's do it together here. 10.3. W naught equals to HF naught. 6,63 times 10 to the power negative 34. All right. Now, what is our threshold frequency? We go back to the graph. Already we've identified it. What's our threshold? Oh, we were given, right? I was almost going to say, how are we going to do it? That's where we didn't read now, right? We didn't read. Okay. The graph cuts the x-axis at what? 5 times 10 to the power 14. So that is our threshold frequency. 5 times 10 to the power 14. What is your answer? 3, comma? And what's the unit? Joules. Somebody solve it. Is it confirmed? Solved? Solved already. Okay. That's our new language. Solved. Proven. Confirmed. All right. Are we okay with everybody? Calculate what? The frequency F2 shown. This one doesn't even need physics. This just needs maths. F2. How would you get F2? What do you know that is associated with F2? Let me do this. What is associated with F2 there? Let's do this quickly. Let me expand this. We don't need all of this. I don't know why they gave us that circuit. It's not important. What's important is this. Okay. How would you get F2? There are so many ways. What do you know that is associated with F2? Kinetic energy. Right? So we know, what do we know? We know that what? E equals to what? Work function plus kinetic what? Energy. Now the question is, somebody will say, but there's no F here. There is. Where's the F? In the E. Remember what is E? HF equals to work function plus kinetic energy. Do we know our age? 6,63, right? Times 10 to the power negative 34. Do we know work function? I think we got it earlier on. 3,23, if I remember. 3 times 10 to the power negative 9. Oh, I missed something here. It's F times. Plus, what's our kinetic energy at that point? 11. Please don't forget that it's 11 times 10 to the power negative what? 19. Please give me an answer for frequency. Let's check with calculator usage now. Let's check with calculator usage. Yes, 2 decimal places. Confirmed? 2 comma times 10 to the power of, and what's your unit? Hertz. Frequency. 4 marks there, 1 there, 1 there, 1 on the left and 1 on the right. Let's confirm. I need to make sure we are all getting that. Solved. Okay. Biggie, let's calculate. Did you get it? Confirmed. Solved. Confirmed. Okay. Fumani? Calculator usage? Solved. Kwanele? Solved? Okay. 2 decimal places. That's the last answer. Physics, round off to 2 decimal places. Oh, it's solved. Oh, God. Even online, solved. Okay. Proven, if it was Euclidean geometry. Please, when we practice this, I'd like you to use the calculator because of the exponents. I need to make sure we get the proper use. Okay. The intensity of light is increased while the frequency of light is kept constant. How will this affect the reading on the ammeter? Every time I taught this, I explain it. Increase. Why will it increase? And other examiners would want. What does intensity mean? Increase in intensity. What does this mean? It means there is an increase in the number of what? Photons. Increase in number of photons. Will increase the number of electrons. Will increase the number of what? Electrons ejected per unit time. Now we have to mention that. Why are we mentioning that? About current. Q over delta T per unit time. Therefore, current will what? Increase. However, what happens? Kinetic energy of electrons remains what? The same. Just in case. So this is a full detailed answer. Whatever you want to respond to, you find it there. Increase in intensity means increase in number of photons, which will increase the number of electrons ejected per unit time. And current will, let me say current, I will increase. Current will increase. So let's just write it. Let me write it in blue. Current will increase. However, the kinetic energy remains what? The same. Now, do you see that if you know your first 11 marks in a paper, even if it's the last one you do, at this stage, I'm going to advise you, find the topics that you've mastered well. There's no rule that says you must go from question 1 to question 2 to... Find what you've mastered well, answer those first. Don't rush through what you know and that you are sure of, because you don't want to make mistakes there. It's very important. All right, that question is done and dusted. Generators now. Okay. Let me divide this question into two. This is another topic where learners must get full marks. Full marks. Here, I don't play. We are not going to allow any mark to elude us here. We want 100%. And these are marks, these are questions you quickly do in an exam. Before you used to go and start dealing with so many other heavy calculations. I normally give an outline to my learners. They know that we start with question 6. Start after multiple choice. When we go to question 6 from Doppler effect. Because I want in first 30 minutes, I want you to be seated with 30 marks already. Okay? We'll see. Start with Doppler, go to generators. After generators, you go to photoelectric effect. Those can be done in 30 minutes. So your first 30 minutes, you're already sitting comfortably 30-45 without stress. Then you go back to your choice, mechanics or Coulomb's law or whatever. All right, let's see. The diagram shows a simple electric motor. Once you see this, you must automatically know your energy conversion. What will a motor do? Electrical to mechanical. And I think we've answered the first question. Done. What type of conversion takes place in this motor? We said what? Electrical. Okay, please put the word energy as well. To mechanical energy. You just all right, energy. Again, 1 mark question. You're done. What type of electric motor is this? AC or DC? Yeah. How do you know if it's an AC? You look at that. Or DC? Yeah. Split ring is DC. And I will tell you, D and C is a circle split in 2. Make sense? So if I take a circle, think of. All right. It's a DC. Thank you, Tesmia. DC. So, makes sense. Why are we considering? Oh, give a reason for it. It has what? Please, don't, if you write split rings, you'll be marked wrong. Commutator. In fact, if you write commutator alone, you get the mark. But if you write split rings, the commutator is the main thing there. Slip rings are just slip rings. But this one is split ring commutator. Explain the function of the carbon brush. Allows what? Current to flow. allows current to, but where is current flowing from? This is the motor. It flows from the external to the coil. If it's a generator, it flows from the coil to the external because we are producing. Here we are using. So current is flowing from here into the coil because we are using electricity to allow the coil to move.
So generation from S to N. No. Motors from S to N.
From?
S to N. So I don't want to know this.
S to N.
From north to south,
No. It's fuels that move from north to south. Yes, you can see that test, Mia. It conducts electricity from the external circuit to the coil. Allow currents to flow from external circuit to the coil. Leslie, I want you to sort out your electrodynamics. Guys, everyone, we need to get full marks here. Full marks. So a generator would convert what? Mechanical to electrical. The north and the south is just your field. Okay, we're going to sort that out shortly. So please understand, here we are using power. So power must flow from the external into the coil. If it was a generator, we'll be moving electricity from the coil to the external circuit. It's like your galvanic and electrolytic cell. Electrolytic cell, we are using power, which is your motor. Galvanic cell, we are producing current, which is your generator. The only difference is mechanical and chemical, the source. Okay? For physics, it's mechanical. For chemistry, it's chemical. That's all. All right, let's see. To which terminal of the power source, positive or negative, is the brush labeled P connected in the coil? If the coil moves what? Clockwise. They will always give you two things. You need to figure out the third. They've given us two things right now. What did they give us? They give us the clockwise movement and they give us the field. Let's go back. They give us the field, north to south. Which hand are we using for motors? Left hand rule. Remember, God rules my life. Generators, right. And motors, left. GRML. Generators right, motors left. It's a motor here, so we're using left. Okay, those of you at home, let me try to see if I can find the other crazy physics. I'm going to switch my camera on. Let's see if I can get this, but I don't know. It's too bright. It's bright. Now, if I switch off the light now, you won't be able to see. Yeah? I don't. Okay, I don't know if you can find the other diagram. No, it's fine because I look like a shadow now, so it's a silhouette. Yeah. We can see. Okay. So we're using the left. Is that okay? Motion, field, and current. MFC. Motion. I would just use KFC. Yeah, KFC. But just change the K to M. Okay, sorry. MFC. Motion, field, and current. Okay. Will always go from the north to the south. They should give this thing more marks because it takes time even to explain. And it's just one mark. It's so annoying. Okay. This thing is moving. I don't want it to cram. This thing is moving what? Clockwise. Okay. Check this. It's moving this way. For this to happen, my thumb must be pointing upwards. That's the first thing, right? So I'm the left side, pushing this plate up. So it goes right, clockwise. Now, the way I'm standing now, I don't know current, right? But the field is my second finger. So I think it works for me this way. Because I am pointing to the south. Now, automatically when I open my second finger, current is coming out. So it means current is moving this way. So it matches clockwise. That's my field, and my current is coming out. My south was this. If my south was here, and okay, let's do this. Let's explain. Try to change the diagram. This line, motion, field. Now my current is coming out. If this is moving anti-clockwise, all I need to do is to turn my hand to go in. My field is still going there, and I'm pressing the coil downwards. If it was moving anti-clockwise, make sense? If it was moving, if it's moving clockwise, look, just use a page, create a 3D for yourself. Can I borrow a page here? It's fine. No, this is fine. It's okay. It's okay. Leslie, come here. Just come quickly. Time. All right. Okay, stand here. Just stand here. Just stand here. Why are you running? Don't be camera shy, girl. Making you popular. I know. Okay, now move. Your hair is now doing science. This child. Okay. All right, just stand here because I want them to see. Okay. Stop swinging. The hair is... All right. Okay, so that is your coil. See your coil as a 3D thing. Okay? Do you want to hold this coil for me? Good. Now, we are pointing from this north to the south. So I'm pointing this way. North to south. But they are telling me that this thing is moving where? Clockwise. It means this coil is rotating this way. For this to rotate this way, I've got to push up here. Right? So I'm pushing the coil. It goes that way. All right? Is that fine? Now, what happens? If I bring out the third finger, it's just coming out here. But if we are told that this is moving anti-clockwise, it means my coil is supposed to move. Okay, hold it. How would this thing move this way? I've got to press it down from here. And that's my field again. Field is north to south. By the time I bring out my second finger, where does it go? It goes where? Inside. And that's all we do. Even if it's a generator now, you use what? Right hand. Are we okay, everybody? I hope it makes sense. So let's move to let's try to see if we can get it right back in there. Okay, so current is now going this way. Is that fine with you? Current comes this way. I wanted to see something here. Current comes this way. And current will always move. So that means we go that way. Current is moving this way. Does that make sense? That's the flow. Current will move from the positive to the negative. Which one will be positive there? Current normally leaves from the longer end and comes in. So current leaves that way and comes in there. Do you notice it is coming in here and it is leaving that way? So this is my positive and this would be the... So what is P connected to? Negative. All right? Current would leave from the... So the idea is to get the flow of current. Once you get the flow of current, you will be okay. All right, guys, I hope it makes sense. We'll try to find more questions and get that. It's 1 mark and something you must quickly get and move. Generators right, motors what? Left. We'll find more questions to test that. All right, so it's... what are we talking about? What's our answer? Negative. Done. I'll find a question that we need to quickly do on our own. All right. Name and explain the basic principle on which a motor works. Motor works on the principle called the motor effect. Generators work on the principle called the electromagnetic induction. Right? Motors work on the principle called the motor effect. And how does this work? It's simply, I don't know if you guys know, what happens is when you pass current through, remember we are using current, right? When you pass current through a coil or any metal, it becomes a magnet. When you pass current, see, if I have a metal and I connect it to current, it automatically becomes a magnet. This is how if you go to a scrapyard, you see these big things that they use in lifting cars. So they switch it on, current will pass through, it becomes magnetic, it takes the car, and then we move. When we get to where we want to drop it, we switch off. All right. When I did a project like that in high school, a doorbell. So when you press the doorbell, not this new fashion ones that sing, we had this gong, the grrrr. Okay, the one in your schools also does that. It's a circle like this. It's called a gong and a little hammer. That's how it is. So what happens is we pass current through this thing here. It becomes electromagnetic. And then it draws this. But because this thing is elastic, it draws and comes back. So it keeps going. That's how a doorbell works. But it's very fast now. Okay, so that's what happens. How is this in here? I want to show you something. So, when a current passes through a wire, the wire becomes what? Magnetic. Let me give you a quick note on the motor effect. I want to give you step by step. Number one, current passes through. Current passes through a coil. When we say a coil, it could also be what? A wire. The wire or the coil becomes what? A magnet. If it becomes a magnet, it means it has a magnetic field around it. A magnetic field around it. But number three, it has a magnetic field, but it is in another field. Remember, we have a magnet already around. So you have two fields. You have the field of the magnet, and you have the field of the electromagnet. There are two magnets. There's north and south magnet. When I say electromagnet, I mean the coil that was changed into what? A magnet. So we have two different fields there. And we have two different fields. What happens to the magnetic field? Like will what? Repel. It is that push that rotates the coil. I lost you. We have a magnet. It has its own field. So you have, check this. You have a magnet which has its own field. North to what? To south. I have a coil. And I pass current through it. It now becomes what? A magnet. Which automatically, when I say it's a magnet, it has its own what? Field. So you have two magnetic fields. And what happens? Like poles will do what? Repel. Repel means it's pushing. And once it pushes, it rotates. That's the principle behind it. So it rotates, it falls freely, comes back again, is pushed again. And that's how it keeps what? Rotating. That's the principle of that's the principle of motor effect. So current passes through a coil. The coil becomes a magnet, which means it has a magnetic field. All right. The interaction between the magnetic field of the magnet and the magnetic field of the electromagnet. When I say electromagnet, I created it, right? Electromagnet. This is the full detailed explanation. Create a force that rotates the coil, and that's what you want. If you notice, where are we ending? We are ending at rotates the coil, which is what? Mechanical energy. Where did we start from? Current passing through, which is what? Electrical what? Energy. This is the full motor effect. So we pass current through a coil, it becomes a magnet in another magnetic field. The repulsion there creates what? The movement. So the interaction, spelling, interaction, C, between the magnetic field of the magnet and the magnetic field of the electromagnet causes a force that rotates what? The coil. It keeps rotating. No, not electrostatic field. Not electrostatic field. It has to be the magnetic field. Okay, Richmate? It's not electrostatics. It's not about charges here. It's about the magnetic field created by the electromagnet. Oh, sweet. You got it. Just a moment for people to finish writing. All right, let's go answer the next question. Now, calculation. Please understand quickly, when it comes to calculation, what comes out of the socket of our houses is RMS, root mean square. Yeah, just explain, because I said explain the basic principle on which the motor works. I'll just give you full, so just write, because you don't know what to mark them. Okay? Now, please understand that what comes out of the socket of the houses is called what? Root mean square. But I want us to define what is root mean square voltage. That's one definition people, or I don't know how, it's just escapes. You see, you're not giving me, I don't know how to get learners to just, this thing doesn't stay. You've just read, Fumani. Fumani, you just read. RMS, let's say voltage. Let me help you. It is the AC voltage. Guys, start alphabetically. You know you are dealing with AC and DC. So start alphabetically. It's AC. You remember now, right? I know once I give you the first part, everybody remembers. Remember it on your own. Okay. It is the AC voltage that what? Produces the same what? Amount of energy. Yeah, even if they heat, it's the energy. As what? As a DC voltage. And please note, it is associated with power. So if they give you power, know that they are referring to what? RMS. Because your P average is what? I RMS multiplied by V what? RMS. So once they give you power, know that the examiner is referring to what? RMS voltage and current. It is the AC voltage that produces the same amount of heat as a DC voltage. If the examiner says RMS current, then you change the word voltage to current. Please try to go over this. I don't know how it just keeps skipping. Every class I go, RMS, everybody go like, boom. Come back tomorrow. Guys, we did it yesterday. Boom. For years. I experienced that for years. All right. Let's quickly answer this. An electrical appliance has a power rating. Already I know that the next thing is going to be associated with what? RMS and either VRMS or IRMS. What is our power? 2000. We're going to be very fast with this calculation, guys. Let's write down what we have. Power is what? 2000 what? Watts. Okay. What else? Please write down all the info for me. Connected to what? 30 volt RMS. Do you see what I just told you? Power is always associated with RMS. So do we have our VRMS? And what? 30 volts. Please write that information down. Okay. Calculate the peak voltage. Formula page and you're done. You know your VRMS. What's our VRMS again? 230 volts. Okay, number one, we are looking for Vmax. What's the formula? VRMS equals to what? Vmax over root 2. Oh, come on. Like, really? Can they do better? Can they bring something more hectic? What is Vmax? 325 unit volts. We're done. We are done. I mean, like, really, can they bring something more serious? What is this? Next calculation I'm running. What are we doing? RMS current. Okay, I'm not coming back here. We're looking for RMS current and what? Resistance. Okay. So we are looking for RMS current and resistance. Okay, let me just break this board now into two. Here we're looking for RMS current, and here we're looking for what? Resistance. How would you get your IRMS? They gave you... Oh, so P average equals to what? IRMS multiplied by what? VRMS. What's my power average? Ah, beautiful. Do I know IRMS? No. Do I know VRMS? 230. So can we get IRMS? 8,70. What's the unit? Amps. Another 3 marks in the bag. Make sense? Just play around with your formula page. Number 3, how do we get resistance? Use your electricity formulas now. You can simply use VRMS equals to IRMS, Ohm's law. That's one. You can use P what? Average equals to what? I squared RMS multiplied by R. You can use P average equals to what? V squared RMS. Too many options. Too many options. You want to get me resistance, everybody? I'm not going to do that. Quickly. I'm already tempted to write. Okay, let's confirm. Let's use the first one. What's our VRMS? I'm using the first one, right? It doesn't matter, baby. It's okay. We'll prove your answer. What is 230 divided by 8,70? Done. Yes. Can you see 9 marks? What did you do? Divide both sides by 230. The shortened version is, okay, you're asking for the shortened version of that explanation. It's just to say that the magnetic field in the coil creates what? A force with the magnetic field of the field. Just me. Huh? The magnetic force, the magnetic field in the what? In the coil would has an interaction with the magnetic field of the coil, and that creates your movement. I was just explaining from the beginning when you say already the no current is passing through. Okay, so you are just writing the last 0.3. That's what you're basically writing. 4. Okay. Yeah, it's fine. It's allowed. It's okay. It's okay. Because of the squared. All right, what do we have here? Something that looks lovely. This is now real physics. It looks lovely. Something that's not what nice. No, it looks nice. Can you tell me, by reading, what topic do you think we're doing here? Vertical projectile what? Motion. Okay, let's see quickly how to work around this. Ball A of mass 0,01 is dropped from a point. Please, I know that a lot of us think that something is dropped, you say 0. No. I've always, had that misconception. Dropped, ask yourself from the point at which it's been dropped. If it's dropped from a stationary point, then it's 0. If it's dropped from a moving object, it is the velocity of the moving object. I hope that makes sense. If I drop something from a stationary point, then initial velocity is what? 0. But if the object is moving at, a car is moving at, or a hot air balloon, since it's vertical, moving up at 10, and then I drop an object, it's no longer 0. The initial velocity is what? 10. So let's always ask ourselves that question. It's dropped from a point. Okay, here we know it's dropped from a point. So what do we know? Initial velocity equals to what? 0. From a point P from the top of a cliff, 57.5 meters above the ground. At the instant the ball passes point Q, below P, a second ball of mass 0,2 is thrown downwards. So we have another object B. All right? Thrown where? Downwards. But that is how many after what? Okay, they said when it passes point what? Q. So please, this one you need to read carefully. What is the mass of B? Okay, MB is 0,02 kg. Both balls hit the ground at the same time. Let's quickly check something here. Which one is traveling faster? No? When we talk about vertical projectile, mass has nothing to do. I once played a video here, if you remember, with the ball and the feather. No, it was a ball and a feather where there was no air. It's a free fall. Both of them would hit the ground at the same time. A ball, a heavy ball, and a feather, just a normal feather, like get a bird, just pull out one thing from the bird there. All right. Okay, of course you are expecting that the ball should hit the ground. That happens when there's air resistance because the ball is heavier. But in a vacuum where there is no air, where we are saying the only force acting is the force of gravity, both of them will reach the ground at the same time. Do you know why? When I ask you to calculate the final velocity, Vf equals to what? Vi plus A, there's no mass involved. Check again. If I say Vf squared equals to Vi squared plus 2A delta Y, there's no mass involved. Makes sense? If I say delta y equals to vi delta t plus half a delta t squared, there's no 0, this is 0, 2 and 0, 1. We're not getting. Why? The objects are moving at the same acceleration of 9,8 meters per second. Yes, the feather and the ball it is. Okay, so which one is traveling faster? It's definitely B. Why? It was thrown later. 2 seconds? Did they say a second? Did I miss it? Okay, so, yeah. So already you are picking time when we're not given the time. Yes, Elvic, your question? Yes. No, around. So we are saying, make an assumption that we are in a vacuum. But they told us to ignore. So no, I'm not, but they told us to ignore. So when they say ignore air resistance, it means that we ignore air resistance. And if we ignore air resistance, it means we are in a vacuum where there is no air. So the only force acting is the force of gravity. That is what actually makes it a free fall. My answer is yes. It doesn't matter. How many forces are acting on it? No. What is an applied force? An applied force is a push or a pull. It's a contact force. So it is only an applied force if it is still in contact with your hand. Immediately it leaves your hand, it's only gravity, and that's when the free fall begins. Elvic, your question? Yeah, that's why we said ignore it. No. If we are not ignoring air resistance, then it will affect the speed of the heavier object will go through easily than the lighter object. That's why we say ignore what? Air resistance. Because we want the only force acting to be the force of what? Gravity. Which is not really true. That's why we say ignore what? Air resistance. We want it to be a free fall. No, it has nothing to do with mass. Because all my formulas here, do you see mass there? No. So is B a free fall? All right, yes. Why? The only force acting is the force of what? Gravity. The only force acting is the force of what? Gravity. And that happened because they told us to what? Okay, let's run quickly to get to calculations. Now, calculate the time. I'm just going to do this so that we can see the questions. Each of the formulas. Baby, write down what you have. Go to the formula page. No. Good. Write down the information that you have. Then you go to the formula page and check which formula has what you need. I'm going to use all of that system just now when we read. So your job is to read carefully and keep writing the parameters that you have. Okay? Look at this. It says, the first question says, calculate the time it takes for ball A. So we are only focusing on A. To reach what? Point Q. Let me do this so that, because I want us to get this thing. It's not as hectic as people claim it to be. The thing is, we want to do so many things at the same time. Let's follow a simple process. Check this. Calculate the time it takes for ball A. Let's go look at ball A. What do we know about ball A? It was dropped. So I know that my initial velocity, that's why we read, equals to what? 0. And because it's a vector quantity, we use direction, right? So I'm going to say take down as positive. How is the force of gravity acting? Downwards. G, I like to do this, just to remind myself. Down. Take down as positive. What do we have? 9,8 meters per. This is what you do. This is why you get, if you don't do this, you get confused on which formula to use. Again, we're still dealing with ball A, right? Let's go back to the question. It says, ball A to reach what? When you want to do vertical projectile, always ask yourself of something. You need 2 points. Your start and your stop. Or start and end, whichever. Where are we starting from? We're starting from the point it was dropped. Point it was dropped. And where are we ending? We are ending at what? Point Q. All the information that I will take must be from those points. So do we know the velocity at where it was dropped? Yes. 0. Q. Okay, let's go. What do we know between when it was Q? The displacement. Now, the displacement, okay, please look at this. Don't go to the formula yet. So don't get confused. Don't go to the formula yet. That's the problem. What is that 16 meters? It is displacement. And the object is moving where? Down. Now, we said down is what? Positive. So my delta y is what? 16. Don't be in a hurry to go to the formula page. What am I looking for? I'm looking for time. Now I have everything I need. Go to the formula and find the correct formula. It becomes easy when we outlay things like this. Which one has all of this information? You're looking for time. Which one? Delta y equals to what? Vi delta t plus half a delta t squared. It has everything I want. What's my delta y? 16. What's my initial? 0. Multiplied by what? Half. What is my a, which is g? 9,8. And you are looking for what? T squared. It becomes very easy. 16 equals to what? 4,9 t squared. What is my t? We divide both sides by 4,9. And then we find the square root. 1 comma? Done. You see, you want to skip this. No, but you cannot go to this formula. Check. No. VF and VI. Ask yourself, do you know VF? Do you know VF? No. So you cannot use it. All right, so don't try to be a superhero. Even me, I don't do that. I list first. It makes life easy for you. I should give you velocity at the start. The beginning velocity. What is final? Velocity at the end. Done. Make life simple for yourself like that. Okay. Now we go to the next question, right? Please don't rush it. Once you start rushing, you start making mistakes. Let's see the next question. The initial speed. Initial. What is initial? VI. with which ball B is thrown downwards so that the balls reach the ground at the same what? Time. Let's check something here. How do we navigate through this calculation? It says we are looking for the initial velocity of B. Is that okay? With which B is thrown downwards so that they both reach the ground at the same what? Time. Hold on. We have to think here. What do we know about ball B? Do we know the initial velocity of ball B? Okay, check this. Let me write B here. We don't know. Do we know the final velocity of ball B? No. Do we know the time that ball B used in travel? No. But do we know G? 9,8. Now, let's go back to the diagram. Do we know the entire distance traveled by ball B? It is 57, what? 5. You see, we don't rush. Delta Y is what? 57,5. I'm looking for the initial velocity. Okay, hold on. Which one travels faster? Ball B. Wait. What did we calculate earlier on? We calculated the time that it took ball A to reach what? This point, right? Which was 1,81. Let's go back to the question. Ball A of mass is dropped from point B. I want to check where point B is thrown from. At the instant that ball B passes point Q, a second ball B is then thrown. It means we released ball A and waited for 1.8 seconds before we threw B. I don't know if that makes sense. Because we threw ball B when this one got to what? Point Q. But after how many seconds was that? 1.81. Now hold on. If we were to calculate the time, watch this. If we were to calculate the time it took ball A to reach the ground, I'm just going to use an example now. Let's say it took ball A 10 seconds to reach the ground. How long do you think it took ball B to time? How long did it take ball B to travel? (10 minus 1,81). It's less than 10 because it was delayed, but both balls reached the ground at the same time. So if I can, because I have all the information about A, can we look for the time it took ball A and then subtract what? 1,81. That will be the time it took what? Ball B. Does that make sense? Okay. Let's all find the time it took ball A to reach the ground. I told you there's a start, and I want you to check which formula now. Let's make a list. We want to find the time, everybody. It took ball A. We're focusing on ball A to reach the ground. Arithmetic, I'm repeating now. We need to find the time it took ball A so that we can get the time it will take what? B, because they both hit the ground at the same time. So let's find the time it took ball A. Everybody, you have your information. I see Tesmia giving me 3,43. I'm not sure. Is that the answer? For ball A. Let's check for ball A. Do we know the initial velocity? Initial velocity of ball A is what? 0. Do we know the displacement of ball A? Remember, it is now from the start to the ground. Let me thank you, Biggie, for that word. To the ground. What is my delta Y? 57. So always ask yourself, start, end. You pick the values from there. Do we know G? 9,8. What are we looking for? Please, final velocity is not 0. Don't say because it hits the ground. Final velocity is not 0. Baby, what formula would you use there? The same one. Now it's easy. List it. So what do we have? V, what did we use? Delta y equals to what? Vi delta t plus what? Half a delta t squared. What's our delta y? 57,5. 0 multiplied by t plus half. 9,8 t squared. You said your t is what? That is the time it took ball A to travel. But ball B was released 1,81 seconds later. Do you know we now have the time it took ball B to travel? 3,43 minus 1,81. What is your answer? 1,62. Please talk to me. Ritumeti, are you fine with what we've done so far now? Everybody okay? Any question? All we did was the time now to calculate. So if we go back to our list, okay, we don't know this, but now we know this. Now we know this. Let's make a list. I'm looking for VI, right? Do I know time of B now? 1,62. Do I know G? 9,8. Do I know delta Y? 57,5. What formula would you use? You don't understand why we subtract. There's a delay. It's like, Ritumeti, check this. This is school, home. Somebody leaves home and at 8 o'clock and gets to school at 8:30. Person 1. Now, person 2 leaves at 8:15. Let me use a different value, 8:10, and gets to school at 8:30. Now, person 2 was delayed for 10 minutes. How many minutes did it take person 1 to travel? 30 minutes, right? How many minutes did it take person 2 to travel? 20 minutes. Basically, it was the 30 minutes and the 10 minutes from the 10 minutes delay. So person B was traveling faster than person 1 by simply saying 30 minus 10 to give us what? 20. Oh, now you see. Lovely. Great. Do we have a formula now? Okay. Baby, do you see how easy is it to pick a formula? Very easy. We write what we have. You said we should use the same formula. Delta Y equals to what? Vi delta t. So we don't have a final velocity. So any formula that has to do with final velocity is thrown out the window. What do we have? 57,5. What's our initial? We don't know. Do we know time? 1,62 plus 1 over 2, 9,8, 1,62, all what? Squared. Do we know how to do the maths? Please and please don't add these two together. We see that a lot. It's still maths. 7 bananas plus 3 oranges doesn't give us fruit salad, please. I was trying to teach my grade 8 how to add X and Y. Ooh, gave them lots of examples. When they brought the issue of fruit salad. Then I changed my mind. I said, okay, what if you have 5 pencils and 3 crayons? I said it's a pencil case. Okay. Those boys are just out of order. And I'll try to look for something that they'll just look for a way to counter, just for them not to. All right, 50. Let's do this together. 1,62 VI. What would this give you? 12, all right, lovely. I'm glad you didn't round off. So what do we do? You two, that one goes there, and then becomes what? A negative, right? Makes sense? Becomes a negative. So 57,5 minus 12,85956 equals to 1,62 VI. Whatever answer you get, you divide both by side what? Okay. What's my VI? 4.6 or 5.6? And what's your unit? And it was thrown downwards, right? Oh, they said speed. So we don't need the direction. I would penalize you. It means you don't. It means you don't know what you're doing. It means you don't know what you're doing because speed is a scalar quantity. If the question had said velocity, then the down must be there, and if the down is not there, you lose that mark. Okay. Are we okay with the calculation, guys? So, understand the question, read the question, write down the variables that you know, look for the right formula, substitute. The key is you cannot do a vertical projectile motion without a start and a stop. And the values you should pick should be in between where you're starting and when you are stopping. All right, next one. Calculate the speed of ball B just before it hits the ground. What are we looking for? I know we are looking for speed. What speed? All right. Now you see, you said the difference between, now you know. What do you now know, guys? We are looking at ball B. We know it. We know everything. Okay? Give me what we know. It's the final velocity. So we are looking for V final. Do we know V final? Because that's the velocity with which it hits the ground. Just before, it's just when it hits the ground. Before it stops. Because if you say the final velocity is 0, you know what it means? It didn't hit the ground. If the ball is coming down and you say the final velocity with which it hits the ground is 0, it means when it wants to hit the ground, it stops. Just before. Makes sense? All right. Guys, what do we have? Give me a list of what we have now. We have VI, which is what? 27,56. What else? G is 9,8. Do we know time? If you want to. This one now you can use as many formulas that you want to use. VT squared. Do you have VF? Yes. Do you have VI? Yes. Do you have A? Yes. Do you have T? You're done. All right. So, VF, what's our VI? 27,56 plus 9,8 and 1,62. We're done. What's your answer? 43,44 meters per second. Confirmed? All right, it's fine. So we can also use what? VF squared equals to what? VI squared. Do we have all this information? I think we do. Do we have our initial? What's the initial? 27,56. Yep. Squared plus 2. Just a second. What's our displacement? It's okay. And then can we just do the calculation to confirm? You find the square root, right? That's how easy it can. That means you chose downward as negative. If you choose downward as negative, there's nothing wrong. But just make sure every other thing going down is negative. And what are the things? Velocity. The only thing that will not be affected is time. Your displacement will also be negative. Anything going down, if you choose down as negative, you get negative. Okay. Please quickly ask questions here. You want the diagram? There we go.
Right. It says before, like just before it gets to the ground.
Yeah.
Why do you use the same definition? I think that's 5, 6.5.
No. It hits the ground with that velocity, 57,5. That's what it travels before it hits the. Okay, quickly.
So if we were to finish the question, right, and we have to solve it simultaneously, right? So we say the second later, right? That's how we like.
A second later.
Yeah, and then try to solve it simultaneously.
All you need to do, if they say a second later, then the time for ball B will just be t minus 1. And you expand and solve. That's all.
So we don't simultaneously solve it.
You don't need to simultaneously solve it. I'll find a question in my head. I think I know where I can get a question for you on that. What I want to say is, guys, if you choose downward as positive and the ball bounces upward, please change your direction. Just keep it that way. No. That's what I'm saying. Don't change the direction. Just keep it that way. You have said down is positive. Even if the ball goes into the sky, comes down to the ground, disappears, keep your decision to say, I am choosing my downward motion as positive. Don't change it. Because you are saying, I am basing on my calculation on this direction. Please. Once you start changing, you start messing things up. All right. What do we have? Ball B. Okay. So we're done with our first 3 questions there. Let's run through this. No. Ball B is in contact with the ground for 0,02 seconds. Okay. All right. Ball B is in contact with the ground for 0,02 seconds from where it bounces back with a velocity. Just what I was saying, right? If you have to calculate anything, please don't change your direction. Just keep it that way. So this is what we have. Ball B hits the ground. Is that okay? What happens? It stays on the ground, though, before it bounces for 0,02. So if I were to draw a displacement time graph, it would be like that. And then it bounces back up. But what's the time frame here? 0,02. And it bounces back up with a velocity of 20 meters per. Are you aware that this would now be negative? Because we chose downward as. What was this velocity again? Yeah, when it hits the ground. 4.3. 4.4. Okay. Down. Now, what are we looking for? Calculate the force that the ground exerts on the ball. Examiner is now bringing in force. What comes to my head is to say F net is equal to change in momentum over change in time. Because there is a force involved. What is my change in momentum? This is m Vf minus Vi over. This is the place now that we are introducing what? Mass. Do you notice all along the mass had not played any role? But we know F net equals to Ma. Okay? All right. Which object are we dealing with? Object what? B. So what do we have? F net equals to, what's the mass? What's the final velocity? Negative 20. Minus, what's the initial velocity? 43,44. What is the time? 0,02. Let's confirm the mass again. Are we sure it's 0,02? Let's just check quickly the mass of that object. Where is it? Okay, 0.02. So let's get F net. It's okay. So F net equals to what? Negative newtons. Then, wait, you cannot write negative and write up. Now, this is not the final answer. Read the question. The question did not say calculate the net force. Calculate the force that the ground exerts on the. When we say net force, it is the sum. Now let's see how many forces are acting here. Let's see. That's the ground, right? The ball is going to hit the ground. There's a weight going down there. And the ground is also going to exert that force there. All right? Force of ground on ball. The total is what we call what? F net. Oh, sorry. No, I meant F off. That's why the ball bounces back up, because the ground exerts a force on the ball. Okay, baby, just hold on. So, please understand the word net. If you look at the question, examiner is now specific. They didn't say F net. They said the force that the ground exerts on the ball. Okay, Tess, now it makes sense. Now, what is F net? It is F of the weight of the ball, because the weight is also exerting a force, right? And the ground is also exerting. The reason the ball doesn't go into the ground is because the force that the ground exerts on the ball is bigger than the force that the ball exerts on. I don't know if it makes sense. If you throw a heavy ball down, a very heavy ball, it could break the ground. Ah, lovely. What about what? Newton's third law. If object A exerts a force on object B will what? Simultaneously. That's where you're going to say, shouldn't the forces be equal? But go back again. The object will accelerate in the direction of the net force. If the net force is 0, the object will just stay on the ground. Acceleration will be 0. Okay. All right. So this is what we are saying is the object bounces back up, which means there is a force acting on the ball which is greater than the force with which the ball had. If they were equal, the ball would not bounce back up. Because F net would be equal to what? 0. And acceleration, if acceleration is 0, it means the object might not be moving. That's one. Number 2, it is an inelastic collision. There was a loss of speed. It hit the ground at 43,44. Watch this. It bounces back at what? 20. It means some of the impact was lost. It's not an isolated system anymore. Some of the energy was how would you know the ball hit the ground? Vibration, sound. So all of those things make up your F net. So what do we have here? This one is going to be positive, right? Downward is positive. This one is going to be? All right. And this is what we are looking for. So F net is equal to Fg plus F of the ground. Don't let me write Fg. This is weight of the ball. That's what the ball exerts on the ground. What's my F net? Negative 63,44. What is the weight of, what's the mass of the ball again? 0,02 multiplied by what? 9,8 plus F of ground. Do the maths for me quickly, everybody. I think you had something similar in your prelims. Okay. It was the same. This is free state, I think. I'm not sure. The same concept. In your That's why the ball bounces back. No, the force that the ground exactly is larger. That's why the ball goes back in the direction. The ball will accelerate in the direction of the net force. Do you see how force is negative? Which means what? Up. So the ball goes back up. Quickly, give me an answer here. Get it now? All right. What's your answer? And it makes sense that your answer is negative. Why? It is the ground that is exerting the force now on the ball. And we chose downward as anything becomes negative. So what is F of the ground? What did you get? Negative 63, which is what? 63,67 newtons. Where? Up. Sorry? All right, anyway, write down the acceleration of the ball when it moves vertically upwards. Oh, is it negative? I just told you. Don't change the direction. Just told you that. When the ball, once you say downward is positive, if the ball goes back up, don't change the acceleration. What's our answer? 9,8 meters per second, and it is still downwards. The ball is that is why the ball will hit a zero. No, it's not a trick question. Already we are. How is gravity acting? Done. Whether the object is moving up or down, gravity is always acting where? And what's the value? Good. Where? Done. No matter what. No matter what. Okay, let's see. People are saying 63,64. 6. Okay, guys, please can we, Bibi, you gave me 6,7. All right, are we okay with the explanation so far? Please, let's understand, and we've made it easy. Take your time to read, understand what's going on. Keep writing the things you have per stage. Go to the formula page, and once you pick a direction, stick to it. Stick to it, okay? We okay, everybody? Let's see. I'm listening to another question, guys. Yes. All right, quickly, let's see. When did I say the break is? All right, so we started late though. Okay, so we can only take 10.
So other people didn't put their break. They were sitting there waiting. I'm used to that.
So we can only take 10, but let's see, because we have momentum, vertical projectile, Doppler. Then, so we have 3 more questions, then we can go to chemistry. All right. Okay. I'll start again at 18:30. What? Let me just stop this one quickly.